Okay, today we're going to look at sine curves as they relate to springs. So I know we've been covering sine curves and pendulums and springs, and we've done a lot of combining them together. This is our last combination, combining springs and sine curves. So we kind of already looked at it tangentially when we did the lab. We fired our hovercraft toward a spring. We had it hit the spring and start oscillating. And we saw that it formed a sine curve as it oscillated. We didn't really care about the sine curve. Instead, we went and saw what the different relationships were. We saw period versus mass, we saw period versus spring constant, and we saw period versus velocity. We took all that, we made a list of factors and non-factors, and finally we found the formula for the period based on the mass and the spring constant. What we'd like to do today is try to make the connection between that oscillating object on the spring and the sine curve that it produces. So take a moment and draw yourself the actual setup. So we have a spring stand, and we have our mass, and we have some sort of range finder, a pocket lab, a vernier device, doesn't matter. We're trying to measure the position of this mass as time goes on. And you'll notice that when we actually do collect data, we get our sine curve. And I want to make sure that you can relate this to this. So hopefully you remember that when you do a sine curve, one of the first things you do is you bisect it in half. Boom. And that value we called our D. That is called our vertical shift for our sine curve. And how does it relate to this? Well, that D will be the distance to my mass when the mass is halfway through its cycle, when it's right at the middle. Okay? So D on the sine curve, D in real life. It measures how far it is from my range finder to the center of oscillation, the spot where this mass would eventually come to rest. Okay, the second thing we want to do is we want to get the amplitude. And the amplitude is going to be, and I kind of missed it by a little bit, our amplitude is going to be the height of the sine curve. So we can have it there. We could have it here. Okay, this is our A value, and that's determined by how far down I pull my mass. So make sure you know amplitude. How does it relate to this? It's how far down you pull it before you let it go. Okay, phase shift is our third thing. That goes by the letter C, and that is determined by when I hit this collect button. When I hit that collect button, wherever my mass happens to be at that moment zero will determine my phase shift. All of these things are controlled by us. We controlled how high this started away from the range finder. We determined how far down to pull it. We determined when to hit collect. Nature controls the frequency. That's our most important thing. So remember, when you're counting frequency, if you start here, don't count a full cycle till you get back to that same spot. 1, 2, 3, 4, 5 in around 3.8 seconds. Don't count to the top, don't count to the bottom, don't count to the middle. There's no spot that you always count to. You count to wherever you started. Whatever position it started at, when it gets back to that position, moving in the same direction, that's a full cycle. Okay, and then hopefully remember how to take these values and put them into the equation for the sine curve. So you have position, amplitude, phase shift, vertical shift, 2 pi f, that's our B value. Remember that f is your frequency, and that's what you find when you do your number of cycles over time. Okay, so show me that you can relate these two things together. By doing this problem on your own, you'll have a problem just like this, where you'll have a mass on a spring, and you'll have it oscillating up and down. You can hit collect as many times as you want, and it will just kind of change your graph each time. Your goal is to try and get one that's going to be easy to count. So you'll notice I stopped hitting collect when I hit one that was beautiful. I hit one where I started collecting when it was at its highest point. This makes it easy to count. I can easily say, okay, 1, 2, 3, 4, 5, 6, 7 cycles in 4 seconds. That gets me my frequency. I put that frequency in here. I need the amplitude, so again, find the middle of your curve and go up. That will get you your amplitude. That goes in here. And then finally, you need the spring constant. And for that, you do your period equals mass over K. The mass should be given to you in your problem, so read through that. The period, hopefully remember that period and frequency are inverses of each other. So whatever you got for your frequency, flip it to get your period. Solve for K. Be careful with your algebra. Okay, good luck. This will be the end of springs. We've finished our pendulums. We've talked sine curves. So we're real close, not quite perfectly there, but real close to learning about waves and applying them to sound and light. Okay, have a great day.